Okay, good evening to all of you. So I welcome you all for this wonderful session on the latest trending technologies of electrical technology. So it's a third day program of Tech Hour 22 conducted by NoviTech R&D Pvt Ltd, Coimbatore. Okay, is it audible to all of you? Can I get a quick confirmation? Okay, thank you Ramya Selvaraj for your confirmation. Okay, let's enter into the session. So today is a trending technologies on electrical department. Okay, so before I enter into the session, I would like to introduce ourselves to all of you. So we are NoviTech R&D Pvt Ltd is a technological company specialized in product engineering with main focus to industries, automotive and electronics. So and we are doing academic project training for both engineering and arts college students, and we are conducting a lot of faculty development programs and in-plant trainings and internships, and we are now manufacturing the products for top industries by our research and development department. Okay, so without delay, so this is our today's agenda. So what are the topics we are going to see in this session? So first we are talking about the power system, and then power electronics and smart grid, and electrical vehicle, and then wireless power transfer, and SCADA, and Internet of Things, and finally the drone, how the robot is helpful for the electrical department. Okay, so first the power system. So we all know about the electrical energy, no? So it was generated by some power plants like that. Okay, so we will discuss about this briefly now. So basically the power system is a network. Okay, so the power system is a common term. So this is a network. It contains a power generation, and then power transmission and power distribution. These three things is very important for generate the power and distribute to the consumers or the householders like that. Okay, so it uses the form of normal energy, like normal any energy, and convert it into the electrical energy. Okay, so this is the first important point for power generation. Okay, so the power system includes the devices connected to system like some generators and some motors and transformers and other circuit breakers and conductors, etc. Okay, so see, these are the main components of power systems. This power plant, and then transformer and transmission line and substations and distribution line and distribution transformer are the 6 main components of the power system. Now, okay, so see the first slide. So here in this first box, it's the generating stations. It have some the several types of power plants are there. So it generates the electrical energy, and it's step up by using the step up transformer, and it's moved into the transmission lines. Okay, so and then it's given into the substation for the consumer transformer. So it's divided the voltages and given into the customers like factories or some other industries and our people house like that. Okay, so first, so let's talk about the power generation. Okay, so what is the power generation means? So it's simple, the process of producing electrical energy. So this is the term of power generations. We need to create the electrical energy, there is a generation, or otherwise we can say it converting other form of energy into electrical energy. Other form means it's nothing, it's a simple mechanical energy. Okay, so the mechanical energy only will converted into the electrical energy. So for creating this mechanical energy we need some sources. Okay, so electrical energy was developed from the mechanical energy, but at the initial stage we need to create the mechanical energy, no? So for creating the mechanical energy, here we have some sources. Okay, so see the sources of power generation. So here I listed out some energies, some mechanical energies. Okay, so first is a hydroelectric power plant, and then nuclear power plant, and wind power plant, and geothermal power plant, and solar power plant. So these 5 power plants are under the renewable sources. Okay, so renewable means we can replace these all the things. And see the second category, so this is a coal power plant, oil power plant, and gas power plant. So these are the second category under non-renewable sources. We can't get it back. Okay, so let's see one by one. First, the hydroelectric power plant. So I hope all of you have knowledge in a hydroelectric power plant. So I'll give us some short definition about this hydroelectric power. Okay, so it's called hydropower or hydroelectric power, like that. So basically the electricity produces from the generators. So this is the main source of mechanical energy. So generators only create the mechanical energy. Okay, so generators is rotated by the mechanical energy, and this mechanical energy is converted into the electrical energy. So here we need to rotate this generator. Okay, so that's why here we're using the hydraulic power. Okay, so hydroelectric power. So basically it was driven by the turbines that converts the potential energy of falling or fast flowing water into the mechanical energy. Fast flowing water, like a dam, if you are take a dam, so it's one of the fast flowing water, or the it speedily fall down. Okay, so based on this energy, so this water into mechanical energy, and this mechanical energy is given into the generator, and this generator creates the electrical energy. Okay, so in the early 21st century, okay, so assume that early 21st century, so mostly the hydroelectric power was the utilized form of renewable energy source. So this is the only form. Okay, then after that in 2019, so it accounted for more than 18% of the world's total power generation capacity. So it holds that 18% of power in the total world. Okay, so let's talk in the generation of hydroelectric power. So basically this water was collected or stored at the higher elevation, the top of the higher elevation, and led downward through the large pipes or other tunnels, like that. Okay, so to the some lower elevations. So the higher elevations into the lower elevations, the flow of the water. Okay, so let's see the difference in these two elevations is known as the head. Okay, this is the head part. So at the end of it passes down the pipe, or falling water causes turbines to using to rotate the turbines. Okay, so if you are moving the water from the top tunnel to the lower tunnel, so the force will use it to rotate the generator. Okay, so that generator which converts to the electricity. Okay, so and finally see the transformer. This transformer are then used to convert the alternative voltage suitable for the generators to some other transmission lines, like our normal substations. Okay, so see, so the head, this head is given the water flowing. This is the very fast moving water flowing. This flowing is rotating the turbine. This turbine was connected with the generator, and this generator rotate and it created mechanical energy, and finally this mechanical energy is converted into the electrical energy. Then this electrical energy is collected by the powerhouse. This powerhouse then provided the electricity to the transformer, and this transformer, from this transformer we can get a electricity. Okay, so through this transmission lines, and then we can use this electrical energy for our households, industries, then other some other companies, so whatever they are needed. Okay, so this is the working of hydroelectric power plant. Okay, so and then see nuclear power plant. So I hope all of you have knowledge in nuclear power plant, because we are studied in our 12th standard, no? So, and there is two types of nuclear power plants are there. The one is based on the atom, and another one is based on a fuels. Okay, if you are take it by the atom, means it's a renewable energy source. Otherwise, if you are take this as from the fuel, means it's a non-renewable energy source. Okay, so basically it's an industrial site that generates the electricity from the nuclear power. Okay, for example, if you cast the two atoms, that generates the thermal energy, no? So this thermal energy, through this thermal energy, nuclear fission chain reactions was happened. At the time, the heat was produced. Okay, so that heat is used to evaporate the water. Okay, so usually the atoms have some uranium instead of it, so that uraniums also have some electrons. Okay, so at the same time it's release the electrons and the heat energy. Okay, so this heat is used to evaporate the water, and this evaporate water will use it for rotating the turbines. Okay, so and, yeah, as I am told, so it is directly proportional with the thermal power plant. Okay, so where thermal energy is obtained, the nuclear fission chain reactions of uranium atoms from the nuclear fuels, normal fuels. If it is fuels, means it's a non-renewable energy source, no? Okay, so this heat this temperature was used to creating a steam, as I am told earlier. Okay, this steam is used to rotating the turbine. The turbine was connected with a generator, and this generator generates the electrical energy. Okay, so that's it. So here also the generator to, generating means it's a mechanical energy to electrical energy, and the previous one is also mechanical energy into electrical energy, and the next one is also based on mechanical energy into electrical energy. So wind power plant, this is the third one. So I hope all of you know about it, no? So this wind power generation means getting electrical energy by converting the wind energy into the rotating energy. Okay, so first it's take a wind energy and it's converted into the rotating energy, and finally that blades and converting that rotating energy into the electrical energy by the use of generator. So here also we are using the generator. Okay, so at the same time this wind energy increases with the help of wind speed. It's only based on the speed of the wind. Okay, so that's it. And then geothermal. So the geothermal means the same as a nuclear power plant. So because here also we take a thermal energy for creating the steam. Okay, but this thermal energy is taken instead of our earth. Okay, so these power plants use the steam to produce the electricity, as I am told, and then that steam comes from the hot water found a few miles or more below to the earth surface, the middle point of the earth surface, and from this part we are taking some hot water, and this hot water is used to creating the steam. That steam is used to turn on the generator. Okay, this generator is created the electrical energy. So here also the generator into the electrical energy. Okay, so these all are the renewable energy sources. Okay, so and see the non-renewable energy sources. So here see the image. So here the old plants and vegetables or other animals. So it was pressured under the high, it was dipped under the hot pressure and the temperature, and finally it's created some coal. So using by this coal we are creating a some thermal energy. This thermal energy is used to generate so converts the mechanical energy, and mechanical energy into electrical energy. So here also the mechanical into electricity. Okay, so in this non-renewable energy sources there are four major types of are available. So first one is oil and natural gas and coal and nuclear energy. Okay, so basically this oil and the natural gas and the coal are collectively called the fossil fuels, but the disadvantage of this fossil fuel is it's creating some greenhouse gases. Okay, so it's very dangerous one. But see, the 82% of power, electric power, was generated by these non-renewable sources only. So because it was very speed when we are compared with the normal renewable energy sources, so that's why we all are choosing these non-renewable sources. Okay, so that's it. And then power transmission. So power transmission, after generate the power, so using by this type of renewable energy and non-renewable energy, we are successfully creating the power, and then we need to tag this power from one place to another place. So that part is called as a power transmission. Okay, so simply the transmission also have some substations. So every part of unit have some substation. So at this transmission substation, this carries the overhead lines. Overhead means it's nothing, it's have two types of lines, overhead and underground. So normally we all are using this overhead line only. Okay, so these lines which transfer the generated electrical energy that was from the renewable energy sources or non-renewable energy sources, from the generation to the distribution subsystems. Okay, so there is a three parts now: generation and transmission and distribution. So this transmission is the intermediate for generation and the distribution. Okay, so basically there are the two functions are there. The first one is it transport the energy from generating stations to bulk receiving stations. Bulk receiving station means other substation, and then it interconnects the two or more generation stations. For example, one place is located with some solar power plant, and another one have some wind power plant. So we need to move from the solar into a wind power plant. So at that in between the solar and wind, so we can use this power transmission method. Okay, and another one thing, see here, it takes 66 kilowatts and 115 kilowatts. So these are the very minimum voltage. Okay, so the transmission line, if it is above 230 kilowatts, means it's usually referred to as a extra high voltage. So these are the normal voltage. These are the high voltages, 69, 115 and 138, 161. If it was above the 130, means if it is a extra high voltage. Okay, so at that time we need to change the material of conductors. Okay, so this is the point of power transmission. After transmit the power, we need to distribute it to the consumers or customers, like. Okay, so this distribution is the final stage. As I am told, this have only three stages. This is the third stage, final stage in the delivery of electric power. Okay, so it carries the electricity from transmission system to the individual consumers. Okay, so the distribution substations, this connect with the normal transmission system to the lower transmission voltage. For example, in our street we have one transformer. No? So this transformer is take the input from the normal transmission line. So it's step down and it's share it to the consumers house or industries, like that. So based on their requirement. Okay, so this is the power distribution system. So it is the major parts of power system. So generating, transmission and distribution. Okay, so and next we are moving into the power electronics. After getting the electricity into our home, so how can it act like that? So that is the power electronic system. So because we getting a minimum 230 volt of alternative current, no? So we need to share this 230 voltage current to our home appliances. So after getting a 230 volt, so we need some other other electrical conversion method. Okay, so that's called the power electronics method. So study of changing electrical power to this different forms. So see here I have on 230 voltage of alternative current. Okay, so this is our input source from our normal transformer. So we need to convert this 230 volt into our our respected other voltages, like 12 volt for our TV, and then 9 volt so for our if you have a LED bulb, like that, and then 5 volt for our mobile phone chargers, and 3.3 volt for some LEDs, like that. So we need to convert this 230 voltage into the respective 12, 9, 5, 3.3 volt. So this conversion, so in between this 230 voltage and the 12 voltage, it have a one electrical circuit. okay, sorry, on electronic circuit. So that's called the power electronics. So let's see here the supply chain. So here this is the black diagram for converting the 230 volt into our required voltages. See, 230 volt, and this 230 volt alternative current is given into the step down transformer. Okay, so step down transformer means it's nothing, so it's converting the 230 voltage AC current into 50 or 60 or 30 voltage alternative current. Okay, so this is the purpose of step down transformer. I hope all of you know about it. Okay, and then after converting the step down the voltage, so we are using the bridge rectifier. So because our home appliances, the mostly of our home appliances using the direct current, so we need to convert the alternative current into the direct current using by bridge rectifier. Okay, so I will explain about it. And after converting the 50 volt AC current into 50 volt DC, here I am using the some filtering. So filtering means if you are converting the AC into the DC means definitely it have some ripples. So we need to remove the type of noises. Okay, so that's why here we using the wave filtering method. So wave filtering means it's nothing, it's just on capacitors. We need to add some microfarad capacitors. Okay, so based on that electricity power. So now after filtering, so here I using the voltage regulator. Voltage regulator means it's converting the high level voltage into the low level voltage. For example, as I am told, we want only 12 voltage and we want the 9 voltage, 5 voltage and 3.3 voltage. So we need to use the MOSFET for this voltage regulator for converting the high level voltage into low level voltage. Okay, so here we can use the, if you want a 12 voltage means, just take a example, 12 volt. If you want a 12 volt means you need to use the 7812 voltage regulator. Okay, so and if you want a 5 volt means 7805 voltage regulator. So based on this regulator, it's convert to the 50 volt into the respected voltage. Okay, so if you are using the 7805 means it's converting the 50 voltage DC current into the 5 voltage DC current. So this is the use of voltage regulator. Okay, and then after converting the after step down the 5 volt, so it's also have some noises. Okay, so we need to again remove the noises using by filtering capacitors. Okay, so and then finally we get a exact output. Okay, so this is the basic method of power supply. Okay, so converting the 230 volt AC into normal 5 volt or 12 volt or 9 volt DC current. Okay, so see, so I told step down transformer is used to the high level input voltage into low level input voltage. Okay, so and then this is the bridge rectifier. So here we using the 4 number of diodes. So just to see, so I will explain it. Okay, so this is the AC current, so it will move from these 2 diodes. So first initially it's moved from these 2 diodes. It creates the one half wave form. Okay, so half wave rectifying, and then if it moves the another one direction, it's created the another one positive. Okay, so it's created like this. So this half wave is generated by the 2 of these 4 diodes, and another form is created by the another 2 of the diodes. Okay, finally it's created there. It's like the negative wave, it's only getting a positive wave. So this is applied like this, and see this point. Okay, so now, so this is the AC current now. So this is the AC current. Now it's converted into the DC current. So this is the DC current, but it have some ripples. Ripples means nothing. This is called the ripples. Okay, so we need this type of current. Okay, so that's why here we are applying this 2 filtering method, wave filtering and this filtering capacitor. So it is used if you are applying the wave filtering means, so this graph is changed into like this. Okay, so and after again if I apply the on filter using by the 10 microfarad capacitor, so it gives like this. So now this is the perfect DC voltage. So see, so here we successfully converting this type of AC current into this type of DC current. Okay, so this is the basic, you all know about it now. Okay, so and then we move into the smart grid, the extraordinary technology of electrical department. Okay, so now the most of the research is going on this smart grid. So so that's it. So before we start talking about this, what exactly smart grid is all about, so just answer this question for yourself. Look around and see how many electric devices you have which are operating right now. Fan, light, like that. This is the simple one, and you have a one mobile phone. So these are the some electrical devices. Okay, so do a little rewind to your childhood days or early adulthood days, and think about how much of these electrical devices did we have, say 10 to 15 years back. Okay, so we should have got the point of by now. The energy requirement of that we have today has increased multifold. For example, in your 15th age or before 15 years, definitely you have I hope so every home have some basic electronic appliances, na TV, fan, light, like that only. But now we have a AC, washing machine, and our mobile phone and refrigerator. So these all are the electrical appliances. So year by year, so it's the need of electricity is increased. So to go by the statistics, so see the statistics in Asia have grown up by 76% over a period of 10 years. This is a population, sorry, it's a electrical consumption, 76%. Okay, so in from 2008 to 2018, only 10 years, it's records the grown up by 76% of electrical consumptions. But just to say, take a population the same year, so 2015 to 2019, in a 13 years, the population has increased only 15%, but the electrical consumption is increased 76%. Okay, so see, so what is the reason behind of that? So this may be due to multiple reasons, no? So increasing the domestic and industrial needs, and introduction of new devices, as I'm told, the smart devices, and the economic affordability, so which increased the electric consumptions. Absolutely, this is the reason for that. Now, so but we can see a clear picture of the future. So as the electric consumption is rapidly increasing, means so we need to generate and transmit more electricity. No? So we need a more electricity. We need to generate the more electricity. Okay, so at the time it is very difficult. It is very difficult to store the electricity effectively. So we can't store the electricity effectively. So this is one of the major disadvantage. So it has to be generated whenever there is a requirement. So then we generate the power and use it for use case wise. Okay, so to for generating the electricity, we need to require some fossil fuels like oil and coal and gas, like that. So there are renewable alternatives, but we have to find a way to make them as a sustainable renewable energy source. So because these are the fossil fuels are the non-renewable energy sources. So see, again going by the statistics, 85%. So in our normal electricity was 85% of electricity production depends on the coal, natural gas, and the oil during the 2018. But now it is increased. So the major disadvantage of using fossil fuels is that they emit a lot of greenhouse gases, so which will eventually affect our atmosphere and the human being, and results in a global warming method. So apart from the fact that they are non-renewable and limited to use, we can't use it, we can't reuse it. Okay, so that's a non-renewable energy source. So, and see, it's also interesting to note that there are a few peak hours. So this population and the needed of electric consumption is one of the point, okay, for requiring the more electricity. And the second point, the peak hours, so where the consumption of electricity is too high, as the majority of the households, industry, and use them at the same time. If you are using all the appliances and everybody is using some appliances in the same time, that called as a peak hours. So you can take it as a after 7 o'clock, after 7 p.m. After 7 p.m. we all are into our home, so and fan, AC and TV, so these all are the things, or we are using these all are the things, everybody using these things. So this time is mentioned as a peak hours. Okay, so and see, as large amount of energy has to be generated for this short span of time. So we have no other way but to use the non-renewable fossil fuels only. So because it is very easy to very easy to use for generating the power when we are compared with the non-renewable sources. So because it gives the immediate electricity power. This non-renewable sources gives us a immediate electricity power when we compare with the renewable sources. So we all are moving into the renewable sources, sorry, non-renewable sources like coal, oil, like that. Okay, so and see, and also our future electricity bills will also depend on which part of the day we are using the electricity. See, which part of time we are using the electricity. So based on this timing, we are to pay the double amount. For example, if we are using the 100 unit, okay, if you are using the 100 unit between the morning 10 o'clock to 12 o'clock or morning 10 o'clock to 5 p.m. okay, so it's a normal rate. But if you are using the same 10 unit from 8 p.m. to 10 p.m. or 8 p.m. to 12 p.m. like that, means it's double charged. So already our the Delhi government has already started introducing to these consumers with the uses of smart meters. Already they opening this plan that's called the time of the day tariff. This plan so will executed in Delhi by Delhi government. Okay, so and see, so that's we require a few smart systems. So we need some smart system which can help us to understand the consumption of electricity and from the different devices and communicate with generation and transmission grids. So they produce the electricity smartly and then in a renewable ways. Okay, so see, so that's the when the smart grids come into the picture. So by 2007, so it started in 2007, the energy departments from the USA, United States of America, and European Union, so it's take a task smart grid towards the catering to many of the problems of electricity generation and transmission and consumption. So since then this smart grids as a buzzword and the topic of interest, the interesting topic of especially among the electrical and electronics engineers. So from the 2007. Okay, so to give an example, if there is a break of electricity distribution lines, see here the first file, first image. So it's mentioned if there is any breakage of electric distribution line, then the electricity is rerouted through the other way of grid to reach the consumer. Okay, so this is the first part when we are using the smart grid system. If any one of the line was faulted, then it's take another one line for distributing the electricity power to the consumer. Okay, so and the another one, the proposed smart grids will aim to solve the different problems by identifying the consumption of power consumption level and communicate the same generation phase. So and if we are applying the another one technology with this smart grid, okay, so that is a Internet of Things. If we are applying the Internet of Things to that smart grid, so we can, so the basic definition of IoT is we can control and we can monitor the things, anything. So we can control and monitor the thing from anywhere in the world. That is the main definition of Internet of Things. Okay, so if I am combine this Internet of Things with a smart grid, so we can control our home appliances from anywhere in the world. So see, let's consider the simple example. So the washing machine and the electric motor, so these are the very high consuming electrical consuming appliances. So electrical motor that fills the overhead tank in your house. So we can easily run these machines like washing machine and the motors during the non-peak hours. For example, if you are in your office, okay, if you are in your office, but you need to wash your clothes and some other works on regard that. So you can turn on your washing machine from your office using the internet of tech things. Okay, so and the time is a non-peak hours. Okay, so we can run our home appliances in a non-peak hours, so we can reduce our power consumption. So this is the another one method. So the first one is a rerouting method, and another one is we can control our home appliances from anywhere in the world. So this is the second point of smart grid. Okay, so then what is the future of smart grid? Okay, so simply, so many of the top companies in power sector are actively working towards the creating smart grid projects. So mostly of the countries have realized the need of electricity power, and especially the energy department of USA takes a lot of effort towards this. Okay, so we hope in the near future smart grids will take over the process of energy generation, transmission and consumption, so completely, and it will certainly be in a massive scale. Okay, so and guys, if you are a student or a recent graduate professional with a passion towards contributing to the normal transformation of the electric sector, you can certainly get involved into the learning more about this smart grid. Okay, interestingly, so this field requires the experts from multiple domains. If you are a computer engineer, if you are a mechanical engineer, it's not a problem. So they need some experts from every domain. Okay, so you can apply for joining with a smart grid development board. Okay, so that's it about the smart grid, guys. Okay, so and then electric vehicle. So electric vehicle means as per the name, so partially or fully it's powered on electric power. Okay, so mostly EVs are vehicles that are either as I'm told, partially or fully powered on electric power, and these electric vehicles have now running the low cost, by the low cost, and it have a less moving parts for maintaining, and also very environment friendly. So as they're using little or no fossil fuels, no? So if you are using the fossil fuels, means petroleum or diesel like that, it's created the greenhouse gases also. So if you are using this electrical energy for running your vehicles, so it doesn't create any gases that was affected into the environment. Okay, so and see why we need a electric vehicle. That's I'm told yearly. Main reason is emission will be reduced. So this is the first thing, and then efficiency is higher than the normal automobiles. Okay, so and then what are the types of electric vehicles? So see, battery electric vehicle, so that's called the BEV, and plugged in hybrid electric vehicle, PIHEV, and hybrid electric vehicle, and fuel cell electric vehicle. Okay, see, in a BEV means it have a full run with a battery. Okay, so battery electric vehicle, and we can recharge this vehicles by the electric grid system or from the charge station. So this is a real-time example of BEV. That's a Tesla Model S. So it has a driving range of 150 to 200 kilometer range. And then HEV, hybrid electric vehicle. Hybrid means it have a two parts. First one is a internal combustion engine. So it have a ICE as well as it have a battery used drivers also. Okay, so they have a internal combustion engine, at the same time it have some batteries also there, so we can use it wisely. Okay, so the Toyota Camry is the best example for HEV electric vehicle. So and then plugged in hybrid electric vehicle, so they have a both ICE and battery is used, and we can use this as a long driving range, and gas fueled ICE is used for charge when the battery depleted. For example, if you have a if you didn't have a battery, okay, battery level means you can use this use our normal gas station for fill the fuel tank, and you can move to your home like that. So this also the hybrid electric vehicle, but it's in a plugged in hybrid electric vehicle, and Honda Clarity is a example of PIHEV. Okay, and then hydrogen. So in this type, so we are using the gas. Hydrogen is used as a fuel. Okay, so and finally it's also have a some battery. Okay, so this hydrogen generates the power and is stored into the battery. Okay, so at the generation of power, the water is only emitted. This is the very important point of this FCEV. Okay, so these are the 4 types of electric vehicles. Okay, so how the electric vehicles are working? So it's totally based on the embedded systems. Okay, so see, so in our oscillator, it's our oscillator was connected with the potentiometer. Okay, when you are press the oscillator, that potentiometer it gives us a values based on your pressure. Okay, so then the potentiometer values is given into the controller. The controllers take this oscillator value as an input, and it's giving a power supply to the AC motor based on this potentiometer value. Okay, so and at the same time, if you remove your foot from the accelerator, so it's automatically acting as a generator. Okay, so and so we can apply the another some methods. So it's like some other sensors for identify the speed of the vehicle. Okay, so and temperature of the vehicle. So based on these sensors, we can convert the normal e-vehicles into the smart e-vehicles. Okay, so and then wireless power transfer. So this is the another one enormous technology of electrical. Okay, so this WPT, that is a wireless power transfer or electromagnetic power transfer, is the transmission of electrical energy without wires as a physical link. So in a wireless power transmission system, a transmitted device driven by the electric power from a power source, and it's generate the time varying electromagnetic field. So it's take some power source from the take some power from the power source, and this power was converted into the magnetic force. It's create the magnetic field. Okay, and this magnetic field was transmits the some frequencies, and which transmits the power across space to the receiver device, so which extracts the power from the field. So see this image. So this supply is our input voltage supply. So and this transmitter is just a transmitter is converted this electrical power into the mechanical field. This mechanical field is have a mechanical fluctuation, and this fluctuation was captured by the receiver coil, and this receiver coil is converted into the electricity energy to the load. Okay, so okay, so let's see the types of wireless power transfer. So first one is a near field like our NFC, and another one is a far field. So see, in near field or non-radiative techniques. Non-radiative means if you are using the near field technology, means it's have some less radiations because it's the distance is very low, no? So that's why. So it's transferred over the short distance by magnetic fields using the inductive coupling between the coils of wire. Okay, so or by the electric fields using the capacitive coupling between the 2 electrodes is the point of here, 2 electrodes. These electrodes is capturing the input source. Maybe it's a light or some other radio frequencies. It's convert the energies into the electrical energy, light energy or radio frequency energy, and it's converted into the electrical energy. Okay, so and in far field means it's a radiative technique, so also called the power beaming. Okay, and this was used to giving a power to the solar powered satellites like this. Okay, so this is the transmitter, and it have a one laser beam, so it's transferred the laser light. Okay, and it's this laser light was captured by the photovoltaic cell. So there is a solar panel cell, and after getting this laser beam, laser light, it's converted this light energy into the electric energy, and it will be charged. Okay, so this is the wireless power transfer system. Okay, so and then SCADA. So it's also the important technology nowadays. Okay, so SCADA systems are used by the industries. So mostly used by the industries and the organizations and other companies in the public and private sectors to control their machines. Okay, so control their machines and control their and maintain their machine efficiency, and distribute the data for smarter decisions, and communicate the systems issues to help downtime like that. Okay, so this SCADA systems is work well in a many different types of enterprises. So because they can range from simple configurations to large. So that is the point, important point first. Okay, so see, the control industries process locally or at remote locations. We can control the industrial process. So it's also like Internet of Things. Okay, Internet of Things, if you are applying the Internet of Things, so we can control from everywhere, but this SCADA system is controlled within a limit. Okay, so and next we can monitor and we can gather the informations and we can process these informations for other artificial intelligence methods. Okay, so we can read the real-time data, we can monitor the real-time data, we can process on the real-time data and give it this real-time data into the artificial intelligence technology. Okay, and then third point is directly interact with the devices such as sensors. Yeah, if you have some other machines like that was created generating a high amount of temperature, so like if it is a chemical factory or if it is a some other chemical related factory, so it means, so it generates a high amount of temperature, so we need to analyze this temperature and we need to set a threshold for the temperature. Okay, so so based on this threshold level we can take action. Okay, so for that method we need some sensors. Okay, so now after identify the values, we can take action for this temperature high. That means you can turn on the fan and you can turn on the water pumps like that. Okay, so and the next so it's record the data events to into the log file. So it's this log file is very important for rearrange our previous histories. Okay, so and where can we use this SCADA? So it means it's energy related companies and oil and gas and transportation, food, beverage and power and water and wastewater related companies. So we can use this wisely. Okay, and then finally the Internet of Things. As I am told, the early Internet of Things is a technology which was used to taking all the things in the world and connecting them with the internet. Okay, so we can use this Internet of Things method in our transformers or substations like that. So we can find the how much of voltages we get, how much of current we get. So these all the things taken by the sensors, and this sensors data is given into the cloud, and we can monitor the transformer. We can monitor the transformer from everywhere in the world. For example, if any one of the power theft was occurred in particular area, so we can identify that also. Okay, using by the sensors. And if there is any breakage, was occurred, so we can analyze at the next second we can analyze that breakage. Okay, so so this is a part of Internet of Things. Okay, so and then so see this, so we can use this IoT for advanced metering infrastructure, and we can use this as a with the combination of SCADA and smart inverters and remote control operations of energy consuming devices. Okay, so we are getting the informations about our transformers and our home appliances in our mobile phone. Okay, so that is the Internet of Things. Okay, and finally the robot, how the robot will helpful for electrical department. So simply see the zip file. So it's a simple example. So it's like a drone. Okay, so this drone it's remove the some unwanted cloths that was placed on the transmission line. Okay, so we can use this for this purpose. Otherwise, if you are applying the artificial intelligence to the drone, so this type of drone is controlled by the human. But if you are applying the artificial intelligence to this particular drone, so it will automatically fix the mistake of transmission line and fix the some error of transformers. Okay, if you are applying the artificial intelligence to the robot. Okay, so that's it. So that's it, guys. So in this session, so we are talking about the power systems and power electronics and internet of things and the electrical vehicle and the SCADA and smart grid and how the robot will helpful for electrical technology. So these all are the things we discussed it today. If you are have a any doubt or any queries about these sessions, you can mention it in a chat box. I will wait here for your questions. Okay, guys, if you are like this session, kindly give your a like, click a like button and share this video with your friends. And if you want any queries means, you can mention it in the chat box. Okay, Dinesh, Ashok Kumar, no questions, sir. Okay, thank you. And next, any other have questions regarding these technologies? Okay, guys, we are support you on this type of technologies, embedded system, artificial intelligence, and power electronics, power systems, so and renewable energy sources like this, e-vehicles. Okay, if you want any courses or any internship levels means, you can contact at these numbers. Okay, these are our office locations.